Hello, welcome to today's class on AutoCAD Electrical. Today we'll be treating Module 10 and our topic is Schematic Diagram. First, what is a schematic diagram? Schematic diagram shows a schematic of everything we've done in our design plan. It gives you a simple diagrammatic explanation of all our interconnections between the different components and layouts in our plan. Okay, what we'll be treating involves about a schematic diagram. We're going to talk about the schematic diagram. The components of the schematic diagram, we're going to see all the components of the schematic diagram. Creating power sources. When you create power sources from the power holding distribution, or through the generator source or any other source, maybe a solar source. Creating all electrical components. Example, the GS switch, the ELCD, bus bar, the distribution board. These are the components we will find in our schematic diagram. We're going to create them and we're going to assign ratings to them also. Then creating the earthing component. Yeah, the earthing also comes here in our schematic diagram. We're going to show how the earthing is connected to all the interface. Then we'll be connecting all the components in the schematic diagram. We're going to show all the connection between every component in the schematic diagram. Okay, that's about the schematic diagram. We're going to go to our AutoCAD environment where our design is going to take place proper. Okay, this is our AutoCAD environment, and this is a sample of our schematic diagram. Okay, let me make this. Alright, this is a sample of our schematic diagram. What we can see here is schematic diagram. Okay, first I want to look at the source. To start with this. This is our source, our power source. We have the power distribution, battery distribution source here, and we have our generator source here. This is our generator in our building. So from this building, we have the design. We have two sources. The direct from the power company and our generator. Okay, you can see these are wires connected from the power holding. This means that we're using a three-phase here. You can see it is connected to, first it's connected from the source here down to a fuse. This fuse is attached on our building. To the fuse that is attached our building where our wire is drawn from this electric pole down to the fuse in our building. Then from the fuse, see that the wire continues and it is drawn into the building. We have our GS switch. The GS switch is what we usually call our changeover, popularly called the changeover, but just the GS switch. It is right there inside our building. Most times it's made up of popular ceramic material. Okay, from the GS switch, you can see it wires are drawn into the building where we have the RCPO. The RCPO means what? The residual circuit breaker and overflow. Residual circuit breaker and overflow. Okay, the RCPO is also one of the components in the schematic diagram. It's also one of the components we use to regulate the flow of electric into our building. So it's a circuit breaker also. It reduces the overflow of electric current that goes into the building, that's the distribution board. Okay, from there, from the RCPO, it goes into the bus bar. Here, what the bus bar does is that the bus bar helps us to distribute electric sources across many components in the building. For example, here we are using connecting it to the bus bar, which takes it to the different floors in the building. For example, this is a story building. So the components of the story building, we have a DB for the ground floor, that distribution board for the ground floor, and we have another distribution board for those on the first floor of the building. Hence, the bus bar is what is used to separate the connection from the bus bar. It takes it down to this distribution board on the ground floor, and also takes it to another distribution board on the first floor. Okay, let's go back to our sources again. I've explained the first source, the source from our power holding company. Now the generator plant we have in our building, right inside our house. We have the generator source here. Okay, the wires connected to the generator are taken also to our fuse in our building. This is our fuse. Then from our fuse, it is taken also connected to the GS switch. I've explained the GS switch. That's popularly called the changeover. From the GS switch, it is connected to the RCDO, that's the residual circuit breaker and the overflow. Then from there, it goes to the bus bar. Then from the bus bar, we can see it is connected to different floors where we have the distribution board. Okay, that's about the two sources. And here we have the earthing. The earthing here is also shown on the schematic diagram. What is the earthing? The earthing is what helps us to protect our building from heavy electric current, heavy electric sources. For example, we have the thunderstorms. When thunder and lightning comes down into your building, it comes with a large number of current, a large amount of current that is capable of bringing down the whole building down. It's capable of igniting the whole structure. Hence, we use a thunder arrestor and the earthing, earth it down to the earth. We take our head as a better conductor, as a mass of conductor. Our earth can absorb any amount of current coming in. So we use the earth to be our absorber. It absorbs all the current coming into the building, hence it wouldn't affect our structure. Okay, this is what happens for the earthing. We have the thunder arrestor. Thunder arrestor is what you see on the top of the building, the topmost part of the building. If you observe on most buildings, you see a tiny broom-like structure on it, like a Y symbol. That's the thunder arrestor. It is at the topmost part of the building because when the lightning and thunder comes on the building, it first of all reaches the topmost part of the building. Hence, before touching the rest of the building, the thunder arrestor takes the total amount of current coming and directs it to its part. Okay, it directs it that it goes down here, goes down, goes down here, and the thunder arrestor you can see here is connected to the RC, that's the residual circuit breaker. So when the part of the current goes here, it triggers the circuit breaker. It triggers the circuit breaker. The circuit breaker is aware that there is a large amount of current that's coming to the building, so it activates it and it is ready to protect the bus bar and it's ready to protect the distribution board. Because if this current could go into the bus bar and enters the distribution board, hence all our components, all our appliances in that building, even the structure itself is in danger. So the current is taken down to the earth, and we can see here it goes down to the earth. This is the earth symbol, and inside the earth we have the copper rods, copper electrode. We're using 100% copper because the copper is one of the best and affordable electrode that we can have. So we're using copper. What happens here is that when the current comes down to the earth, it is split into these sources. I mean the copper rod is split here into the copper rod, and copper rod takes it down to the earth, and the earth absorbs the amount of current. Hence, somebody around might not feel what is happening, but the earth is a good conductor, conducts everything down to the earth. By this, our appliances are not affected, our building is safe, people around the environment are safe because the amount of energy coming from the thunder and the lightning arrested by the lightning and thunder arrestor and is taken down to the earth. Okay, that's how our earthing works, and that's the schematic showing the earthing connected to the rest of the video. Okay, let's look at okay, for the labeling, this is the ground, that's the earth, this is the copper rod. Go to a shop and you ask for the copper rod for earthing, the copper rod for earthing, then you can see how it is, it's take the shape. Okay, we have a wire coming into, we're using a 70 square wire for the connection of the thunder arrestor down to the earthing. Okay, looking at our sizes here, you can see our source here and our source here. Okay, before we could select the size of our fuse here, the rating of the fuse, rating of the jet switch, the rating of the RLCP, we need to see our load. What is the total load? For example, we have two load schedule here. We have 59.9 kilowatts for that of the first floor. So up there we have 58.9 kilowatts, and that of the ground floor we have 61.1 kilowatt. So by the time you add a total load, I think we have 121 kilowatts of electricity in the building. So the building is rated about 121 kilowatts. Now 121 kilowatts is our total load, and you can see that our supply voltage is about 220 volts to 230 volts. So if our supply voltage is about 230 volts, for example, and we have about 121 kilowatts of electricity. So by the time you divide 121 kilowatt by our supply voltage, let's say we are using 230 volts, we're having about 500 ampere. So we're selecting our source as this. Looking at a PHED source, that's the NEPA source, like on NEPA or power holding company source. We're using a 300 ampere fuse. in the sense that if we have about 500 ampere assumed load for the whole building, we have about 500 ampere assumed load. Now, if it comes down to this, the 300 ampere fuse will be able to protect our power source coming in the sense that the fuse here is a protective device. It helps to also regulate the amount of current coming in to the building. Since our current fluctuates between, for the voltage, 220 to 230 volts, starts here to regulate it. So a 300 ampere fuse will be able to regulate the amount of current coming in. This is because for a 500 ampere current coming into a building, the diversity factor might come in because not all equipment in the building will be on immediately the light is coming. It's probability that 50% of the appliances are off, 50%, 60 or more appliances are off. Hence, this 500 ampere in electric. 500 ampere is the amount of current in our appliances. The 300 ampere fuse is going to cover for half of the amount that where the electric current is coming. Here's here we are using a 200 ampere fuse on that also. 200 ampere fuse is what we're using to generate also. Then our GS switch is also rated 300 ampere GS switch. That is where the fuse goes into, and the other fuse here also goes into the 300 ampere GS switch. Now from there, since our fuse here is 300, I think 300 will balance our full connection. So we are using the 300 ampere GS switch also. Our RCBO is also a 300 ampere RC. Bus bar is connected to. Now for the cable sizing, we are using a larger cable here at 95 mm square from the PHD source to the fuse here at 95 mm square. Now from the fuse to the GS switch, we are using a 70 mm square cable size. For the generator, since our projector source will not be much of a current like that of the PhD, so the generator might be just at 220 or 210 volts. So we are using a 70 mm square cable connected to the fuse. Then from the fuse to the GS switch, we are using a 50 mm square cable. Now from the GS switch down to the RCB, 70 mm square cable. From the RCB to the bus bar, 70 mm square cable. Okay, let's look at the bus bar, and now from the bus bar we can see that there are connections from here to different points. You see the first one here is going to be, we have the head bar point inside the distribution board. We have one connection to the bus bar. Then we have here the neutral bar. The neutral bar is also another point on our distribution board. You open the distribution board, check it very well, and you see the head bar, you see the live bars, and you have the neutral bar. So it's connected to the neutral bar. Okay. Then we have the live bars. The live bar that is, and it's connected to the bus bar. Then it's on this note, we have different points on the distribution board. These points are circuit numbers like 1, 2, 3, 4, 5, just like we have here. Circuit numbers. Yeah, 1, 2, 3, 4, 5. Now ascending order. So that's our circuit. That's all we have here. Same thing goes here. The bus bar to the other floor. We have one point going to the edge bar, another one to the live bar, and we have this one to the neutral bar on the first floor also. Okay, that's our arrangement for the schematic diagram. Okay, we've seen earthing, how the earthing is connected to this, and how the earthing is connected also down to the earth's surface itself. Now, for this earthing also, sometimes there are materials which are added here, materials like additives. Additives could be used like charcoal, animal dung. Yeah. What this additive does is that when the amount of current that comes into the earth is used, when the amount of energy, the amount of energy coming from the thunder is directed here, it protects it from a rebound when it bounces back to the earth's surface. The additives here will also help as well to serve as kind of to protect it from, in case there are people on the earth's surface doing their normal business, the additives there will also suppress the amount of water that might go back to the earth, and that's where additives comes in. Okay, this is how a schematic diagram for this building. This building is a story building, and that's the schematic diagram for it. Okay, let's look at another diagram here. This is another diagram, another schematic diagram here. Here we are having three sources. We have a PhD source, we have a solar panel source here, and there's solar energy used in the building, and we have a plant, a generator plant, yeah, generator plant. And here we have our earthing also. Okay, what we are seeing here is the wires going to the sources, down to the fuse. You can see our fuse here. From the fuse, it goes to the jet switch. GS switch connected to another GS switch here. Since we are having three power sources, unlike the former one, we have two sources. We have three power sources, so it's connected to the GS switch. This one connects down. Then this GS switch takes it to the RCBO. The RCBO then takes it to the distribution board, whereby we have our H bar. Part of it goes to the live bar, and part of it goes to the neutral bar. The neutral bar is also on it. So that forms our basis of our schematic. And the earthing also comes in. This is our earthing. We have our thunder arrestor at the topmost part of the building, which arrests the currents coming into the building from the thunder. Then it takes it to the earth. This is the earth surface, and also connects it to the earth rods. It's wired to the earth rods down here, and they are connected to this point. So connected this way. Okay, that's it. It's connected to the earth. Entered to the building. The earth rod we are using here, remember, we are using a copper, 100% copper rod, because copper is a better conductor of electricity and affordable, better than aluminum or other type of metals. So that's a sample of a schematic diagram. This one is for this load, for about a 49 kilowatt load. We are using this as a schematic diagram. So that's another sample of the schematic diagram. It shows the whole connection from the sources, the power sources, solar energy and the plant source, down to the distribution board. So the entire connection in the building is shown here in the work here. So that's how it is. We can see the other, you can see it from the other, you can see it from the other source here. Okay, that's a schematic for this particular design. And we have a schematic for the other designers. Okay, okay, we have a schematic for this other designers. So I think we've come to the conclusion of the schematic diagram. So the schematic diagram shows all the a schematic of all the connection, the wiring, the electrical components as they are used in the building, from the power sources down to the distribution board. And it also helps us to see earthing, how the earthing is done in the building. We've come to the end of today's class. Thank you for joining us. At the end of the class, we should be able to design a schematic diagram. After we put up all our designs, starting from the luminaries, power layout, down to the distribution, the load distribution, and we're done with everything, we can put up our schematic diagram. Okay, we've come to the end of today's class. I thank you for joining us. I hope to see you guys in our next class.